Hi, everybody. We are going to be starting our Module 7 today, and this is all about relationships between variables. Throughout this module, we will be looking at tables and expressions and inputs and outputs. So that's kind of what we will be discussing throughout this unit. So our two vocabulary words today are dependent variable and independent variable. So I want you to think about what those words mean. Dependent. You are dependent on your parents. They provide you with a house and food and money and toys and Xboxes and whatnot. So dependent means you rely on somebody else. Independent means you can function on your own, right? Your parents are independent. And that means you don't rely on anybody. So we use this when we talk about variables. A dependent variable relies on the independent variable to determine what its value is. And it'll make more sense as we go through. But remember, dependent and independent as our kind of key words today. So let's discuss here how variables are related and what is the relationship. We actually have rules for a relationship between two variables. So we can use an input and an output machine to discover a hidden rule that takes a number, the input, and gives you another number, which is the output. So what we're going to do is we're going to say, okay, the input here is 2. And what I'm going to do is I'm going to run the machine and see what the output would be. So if I run this machine, well, here it goes, it's kicking it out. The output here was 4. Now, what if we change the input? What if I want to change the input to maybe 6? Let's see. Let's run the machine. Our output here would then be 8. Let's try something different. How about 4? What's the output? 6. So based on what we were putting in to the machine, how is it changing when it comes out of the machine? So when we do this, right, what is happening to our values? Well, they're changing, right? So when we put it in originally, right, it was 2. We hit run the machine, we got 4. So we got our value of 4. Okay, so let's go ahead and try moving on here. So what would be our rule here? So how would we determine the rule? Well, we can try different numbers and see what happens. So when we did 2 and we got 4, what if we put in 4? We'll get 6. If we put in 6, we get 8. So it's increasing every time, and our rule then would be plus 2. Now let's take a look at a new machine. Here our input is 3. What is going to be our output? Now if we were using our old rule, it would be plus 2, right? So we would get 5, but in this case we got 12. Let's try it again. So here, 3, we get 12. Let's try 4. Let's see what happens. If I put in 4, we get 16. So what am I doing to the input to get the output? Well, 3 times what is 12? That would be 4. 4 times 4, does that equal 16? Yes. So our rule here is multiply by 4. Whatever we're doing to the input will result in our output. So in this case, the input, whatever we're putting in, is our independent variable, and the output is our dependent. The dependent changes based on what the independent is in this situation. All right, so let's take a look in our math book. This is on page 397. So in a relationship between two quantities, one quantity is the independent variable and the other quantity is the dependent. The independent variable, often called the input, does not depend on the other quantity. The dependent variable, often called the output, changes in response to the input for the independent variable. So let's consider the following situation. At top speed, a cheetah can travel about 103 feet every second. The total distance traveled at top speed t is equal to 103 times the number of seconds s. So our independent variable here is the number of seconds. Depending on how long the cheetah runs, will tell us the total distance. Now, without the number of seconds, we can't determine the total distance. So that's why we use that. So the total distance is the dependent variable because the cheetah's distance depends on the number of seconds it travels. Let's take a look at this situation. Suppose Jada earns $5 per hour babysitting. She'll always earn $5 per hour. That stays the same. We call this a constant. The total amount she earns, A, is equal to 5 times the hours H that she babysits. So what is the independent variable here? Now, the independent variable would be the number of hours that she works. That can change in every different situation that she uses. So our dependent variable would be what we rely on the total hours to determine, which would be the total amount, A, that she would earn. H is our independent because that will always change, and depending on how many hours she works, that determines how much she makes. All right, so let's take a look at the top of page 398. We're going to find dependent variables values in a table. Suppose it costs 25 cents to play one game in an arcade. You can use the table to show the relationship between the independent variable, the input, and the dependent variable, output. In the table, the input value is the number of games played, G. Okay, so that's kind of our independent variable. G changes all the time, all right? It doesn't matter how many, but we'll always use the rule 0.25 times G to determine the cost. So we find the output, we replace G with the input. So, for example, if we wanted to say we played 5 games, we would be doing 0.25 times 5, which is $1.25. What if we did times 10? Well, then we would put 10 in for G. 0.25 times 10 would be $2.50. How about 15? So we do the same thing here. We plop it in, and we would get $3.75 would be our dependent variable, the output. So all we're doing is replacing the value that we see here for our variable G and then finding its value. Let's take a look at example 1. Joe bought an iced coffee for $2.95. The total cost of his breakfast, C, is equal to the cost of his food, F, plus $2.95. The rule is F plus $2.95. We can make a table using the rule and find the total cost of Joe's breakfast. His food costs are $5.50, $7.75, or $10. Now, first figure out what is our independent and dependent variables. Well, the total cost of the food would depend on, his total cost of his meal would depend on what the cost of his food is. So these numbers here would be our independent variables, or the cost of the food. So cost of the food, F, is the independent variable. The total cost of his breakfast is C, and that would be dependent on how much the food costs. So now using this rule, we can then solve for these values. Okay, so if you were going to put in each of these values, right, we can use our calculator and that's fine. Here we have 550 plus 295 would be 845. Okay, so we were able to figure that out. And we do the same thing here. We're going to take 775 plus 295 to get $10.70. And we do the same thing here. $10 plus $2.95 equals $12.95. So we're easily able to figure out the cost of his meal, his total cost of his breakfast, based on the rule and the cost of the food. Okay. All right. So let's go ahead and try this with your check here at the top of page 399. A grocery store charges $2.50 per gallon of fruit punch. The total cost C of G gallons of fruit punch is equal to 2.5 times G. The rule is 2.5 G. Make a table using the rule to find the cost of buying 1, 2, or 3 gallons of fruit punch. So remember, we would take 2.5 and replace that with the number of gallons, which would be 1. So this would be just $2.50. Go ahead and try that for 2 and 3. Pause the video here, and then you can find the value. So once again, we're replacing our values here with those values that are given for the number of gallons. And you should find that it would be 250, 5, and 750 as your values. All right, so what if we know the dependent variable, but we're missing the independent variable? Can we then find the answer? Yes, we can. We can work backwards. So suppose it costs 25 cents to play one game at an arcade. The total cost of playing any number of games can be represented by the rule 0.25 times G, where G is the number of games played. You can use a table to find the independent variable, or input, if you know the dependent variable, output, and the rule. Note that in the table below, the output values are $1.75, $3, and $4.25. Because the rule is 0.25 G, we're going to write and solve equations to find the input G when the output is $1.75. So if we know this value, and we know that this is our rule, we can work backwards. We can do the opposite of our rule. Instead of multiplying by 0.25, we can actually divide by 0.25 to figure out that the value here is 7. Now let's try this with $3. If you want to use your calculator, that's fine. So once again, we would take 3. We would divide by 0.25, and you would find that the number of games played here would actually be 12. Let's try it here. 4.25 divided by 0.25. And we would find that we could play 17 games in that situation. So simply working backwards, it's a lot like solving those equations that we did in the last unit, right? You do the inverse operation when trying to find the independent variable value. So let's try this with example 2 on page 400. Each small pizza at the local pizza shop costs $6.75. The total cost C of P small pizzas is equal to $6.75 times P. We're going to make a table to find the number of small pizzas purchased if the total cost is $13.50, $27, or $33.75. Now, we know that the independent variable here is the number of pizzas. The total cost would be then our dependent variable. So the total cost is $6.75 times P, so the rule is 6.75 times P. Now, when we know the output, we can then find what the input would be by doing the inverse operation. So once again, using our calculator, we're going to take $13.50 and divide by 6.75 to find that this would be 2 pizzas. We can do the same thing for 27. Take 27 and divide by 6.75. And we would find that that would be 4. Same thing for our last one. And we would find that the rule here tells us that we have purchased 5 pizzas. Okay, so inverse operations to help us solve here. All right, moving on to our check. Leslie has 48 stickers to give to her friends. The number of stickers S each friend, S is our variable here, each friend will receive is equal to 48 divided by F, the number of stickers. I'm sorry, the number of friends. 48 is the number of stickers. F is the number of friends. I can keep this straight. Complete the table to find the number of friends Leslie gave stickers to if each friend received 12, 8, or 6 stickers. So if our rule here says that we're going to divide by the number here, what we're actually going to do instead is we're going to divide by this number here. So we're going to do 48 divided by 12. So 48 divided by 12 would actually give us 4. So we know that each friend, or I'm sorry, she had 4 friends to divide the stickers into. Do the same thing here. 48 divided by 8 is 6. So we know that she gave 6 friends stickers if each friend received 8. And now how about this one? 48 divided by 6 would be 8. So we know here that she gave 8 friends stickers. All right, moving on to our apply problem. Sandra is placing sculptures on a 3-foot tall base to display in a cabinet in the school entryway. The height including the base B is equal to the height H of the sculptures plus 3. If the cabinet is 84 inches tall, which sculptures will fit in the cabinet? So using this information here and our rule, please tell me which heights would actually fit in the cabinet if the cabinet is 84 inches tall. Now, obviously you have feet here, so you're going to have to be very careful. You're going to have to probably convert this to feet and inches to make sure that you are staying within the correct limits. All right, as always, please remember to email me your answer here. So, folks, that is it for today's lesson. If you have any questions at all, please make sure to send me an email, ask me, let me know. Please complete your homework online and have a great day.